In this video, we are going to be talking about trapezoids and how to find their area. Again, as opposed to perimeter, perimeter being the heavy black outline. If you were to walk around the shape, it's how the distance is all the way around. So this is a trapezoid. Two sides are parallel, while two of them are very obviously not. In this case, they showed them both tilting inward at the top to make it really obvious. What we do know is that it gives us all of the numbers for the outside, and then we have this dotted line here that tells us that the height of the figure, see that 90-degree angle, just as we've talked about in the other shapes, this is the good posture straight up and down line, and that's the height line that we're looking for. So in this one, if we're talking perimeter, which again is just the outside surround, it's going to be 13 plus 28 plus 24 plus 12. And if you add all of that up, the perimeter is actually 77 millimeters. That's what that mm stands for. You will notice that when we add them together, we don't add the little 2 in the corner here because it's not an area. Only areas have those square units to them. So this is the perimeter, not to be confused with the area. Again, the perimeter is just the bold black line that follows around the outside. Area is everything inside of this shape. And that's the harder of the two. That's the one I really want to focus on for this area, is the unit that we're working with. But I do want a reminder of what the differences are in each video. So with area, what we need to know is we need to know the formula. And the formula for this is a little bit different. I like to write it slightly different than most, but it's all the same thing. So area is going to be 1/2, okay, 1/2 the height, and that's multiplied by what we call base 1 plus base 2. Okay, and we'll explain why there's 2 bases. I know that sounds really confusing, but in this instance, there are 2 things that count as a base. I'm going to shift this over so you can see a little bit better, see if we can get that focus in. There we go, a little bit clearer. Okay, so this is our formula, all right? We could write it several different ways. This tends to be the easiest way. So let's start identifying things. Height, as we said, is that good posture, that straight up and down perpendicular height right here. So this right here equals the height. Okay, guys, that is why we have the dotted line. It's not a perimeter mark. It's not actually part of the shape itself, but it is how tall our figure is. Okay, because this one tilts in a little bit, this one tilts in a little bit. Those are the leanings. We don't want the leanings, okay? Now, when we say base 1 and base 2, in this case, it's the top and bottom. So base 1, we just make it cleaner. We put base 1 up top, and then we have base 2 at the bottom. And then you're like, man, 2 bases, but one's a top and one's a bottom. Well, they count as bases because of their location, because technically this shape could be flipped upside down and they would still be considered bases. And that's why, just to give you a little bit of context. So let's rewrite our formula now that we've identified both of our bases and our height, okay? So it's going to be 1/2 times 11, because that is our height right here, all right, times base 1, which is 24, plus 28, which are base 2 at the bottom. And we just do them top to bottom to make it really clean. Base 1, base 2, top to bottom, just like we do a lot of things left to right. Okay? Now, if we look at this, we can use our order of operations, and we need to do our grouping first. I know you're probably used to parentheses, which in this case does work, but we're going to call it grouping to stay consistent. So let's look at these. We're going to move it up here. We're going to say 28 plus 24. No, that's a little bit high. We'll tilt that just a little bit. 8 plus 4 is 12. Carry that 1. Don't forget those simple math mistakes that can happen. And then we have 1 plus 2 is 3. 3 plus 2 is 5. So we have 52. So if we cross this out, we can say 52 is our new number over here when we add our bases together. Now the rest of this can just come down we haven't done anything to solve that yet. So we just keep bringing them down. Now, in this case, I like to make things easier on myself. We have a 1/2. And what we've talked about in class is 1/2, if you multiply it, is the same as divided by 2. So what I'd like to look at here is how we can make this a little easier, because 1/2 and multiplied by 11 ends up in a decimal. And I know some of y'all are still working through some of the decimal knowledge, but we can do this a different way. Because it's all multiplication, and multiplication doesn't matter a crossing. This is an even number, and that's a divide by 2 function. So I'm going to actually go 11 times 52 divided by 2. And this works because if we bring this up, and again, I'm going to slide it up so you can see, if you have 1/2 times 11 over 1, because that's how we put a whole number in fraction form, times 52 over 1, we can actually, and this is the only time it works, is when everything's multiplication, we can do these two together, kind of leaving this to the side, and make it that 11 over 1 times 52 over 2. Now we can actually simplify this, and it'll help us with our multiplication later. And again, the only time this works is if you've got all multiplication to make it work. So that's why it works, okay? Just got to remember those fraction rules. So 52 divided by 2, we're going to knock it over. And that's what I told my students last year. Bring your 52 over here. So 52, the 2 goes on the outside of the house, okay? Knock it over so the 52 is under the house. So 2 goes into 5 2 times. That's going to equal 4. Subtract that, you get 1. Bring down the 2. 2 goes into 12 6 times. So your new answer is 26. Okay, so if we cross that out because we've solved it, we are now left with 11 times 26. And again, you could use a calculator. It would be 1/2 times 11 times 52, but it would still come out to the same number. At the end of the day, the numbers would still give you the same answer. And with that, we are now going to do our 11 times 26, which is our final like deal that we have to finish up. And the final answer actually comes out to, and we're kind of working backwards here because we're working back across this way, but to fill it in, it's going to be 286 millimeters squared. And I could do it on the calculator the way from the very beginning here, which may be easier for many of you, or it may be easier to go ahead and line it up like this, put it all together. Don't skip over the 11, just put it back together and do the long multiplication if you want to do it by hand, which is what I'd like you to do, but it's not required, because these are really big numbers. There's a lot of room for errors here, but getting that practice in, because there are some things that require you to have the ability to multiply out by hand. You're not always going to have a calculator in some of the tests and some of the functions. I know a good bit of next year for y'all is not going to allow calculators at the beginning of the year. So I just want to make sure that those basic skills stay honed. We're not relying heavily on technology for them. But this is our formula. It's area equals half height, 1/2 times height times the base plus 1 plus base 2. And this is how you find them. Now, let's look at a couple other examples. We're not going to solve them, but I want to talk about why we identify which ones we do. So this one is going to be one, again, not going to solve it, but you can see that the height is here. You're still going to get these two as your two bases. This one's going to be base 1. This one's going to be base 2, even though now the bottom one is smaller. It doesn't matter which one's smaller or where it falls. We always want to stay base 1 on top, base 2 on the bottom, and your height is the one that's straight and tall, good posture. So that would be your height. So if we took your formula of area equals 1/2 height times base 1 plus base 2, the height would go back in here again. You put your base 1 here, your base 2 here, and then you would go through the steps to solve. Same exact process as the other one. This one's a little more confusing, and I'll show you why. Because traditionally we think of height as going up and down. But in trapezoids, because some of the sides are not equal, you can see that none of these sides are equal. We don't have a true base, or true height, excuse me. We could say this is the height, but it's not a consistent height. On all of these, you'll notice the height goes all the way to one side and it goes all the way to the other. On this one, you'll notice the height stays the same all the way across, okay? This one does not do that. It goes from 12 yards here to 15 yards here. So you can't use either of these. What I'm going to do, and this might get confusing, is that we're going to turn it real quick. And if you look at this now, here is our 16 yards. That 16 yards goes all the way across until it hits this sloped side. Very similar to our other ones. The sloped sides don't matter, right? It's the body of it that matters. And it is going to be 16 yards on both sides. And we can draw a fake line here. And no matter what point of these two ends, it's 16. So this is actually our height. And that doesn't look right because you think of height as going up and down. But you can see here both of them have 90 degrees. So we've proven that it is a upright and straight posture. Okay, so this is actually the height. And since we turned it, we can now say, okay, well, if that's our height, then this one's going to be base 1. This one over here, and we'll erase that arrow because that's not our real height anymore. This one right here, if my lead does not fall out of my pencil, is going to be our base 2. And let's see if I can write this sideways. Base 2. There we go. So turning it back right ways up, we now have base 1, base 2, and our height labeled. So we have to watch that we don't get something that tricks us, okay? Even though these are both straight and tall and they're both 90 degrees, we can't just pick one at random. We have to have one that's going to be a consistent height all the way across. And the only one that does that is our width, technically, of 16 that we'll have to use here. So the way it would be written was, it would be written as area equals 1/2 16 times 12 plus 15. We would use our sides as our bases. And this is the reason why I wanted to walk through it, is it's one that's very, very different. I keep turning it, trying to make sure you see the difference, but looking at these two right here, we didn't solve either of these, but you can see this is a consistent 5 centimeters back and forth. Okay, there's no change to these heights. These two have changes. We can't use them. We have to find that consistent height all the way across. So remember, sometimes you got to turn your paper. Sometimes it's not going to look exactly like it does on another one. You may have to like think through, okay, what are the rules of my height for these trapezoids and finding the area. Now the math process here is the same. Just use your GEMDOS process or PEMDOS process. You add up the parentheses and then you multiply across. Okay, and that is how you find the area of a trapezoid. And again, there's how we walk through here. We kind of ran into our triangle from a previous video, but it's the same process of have your formula, remember your formula, and then know how to plug in the right answers.